Hey everyone. So here begins our new unit on measurement. Now, lots of you are going to find measurement pretty straightforward. Of all of the units that we do in 10C, trig and measurement are the ones that students usually find the easiest. Now, that means that this can be a great time to boost your mark up a little bit because your marks on your quizzes and your tests can be higher with the measurement stuff. As long as you continue doing all of your homework and you continue really watching your communication, okay? The one thing about measurement is you can lose marks for silly little things. You want to be careful of that. You can lose marks for not writing the unit. You can lose marks for not writing the proper unit. You can lose marks for, what was the other thing I wanted? Oh, rounding errors. Just make sure you follow the directions very, very carefully when it comes to rounding. You know, if it said round to the nearest hundredth and you round to the nearest tenth, that's going to be a half a mark off. So it's just little things like that that you got to be very, very careful of. Be cognizant of it and make sure you're answering exactly like you were asked. Okay, so today is meant to be kind of an introduction into measurement, and we're going to talk about the two main systems of measurement, which is the imperial system and the metric system. Okay, so a little bit of history lesson for you here. Before measuring tools were created, people often used common objects as an aid or point of reference in measurement. Okay, when we go all the way back to ancient civilizations, we see the word cubit. A cubit was considered the length from the tip of a person's middle finger down to their elbow. Now, if you're wondering how old the term cubit is, okay, to put this in perspective, one of the stories that most religions have, as far as, well, I guess not most religions, but Christians, Jews, and Muslims would all share the story of Noah's Ark. If you look back at the ancient manuscripts of Noah's Ark, the Ark was measured in cubits. That's how old this phrase is, cubit, okay? So that was the length of your middle finger down to your elbow was considered a cubit. Then King Henry introduced a yard, and a yard should be defined as the distance from the tip of his nose to his outstretched finger, okay? So that right there would be a yard for me, okay? The hand, oops, sorry, I gotta go back there. My video was in the way of my reading. The hand is the width of a clenched fist and is still used today to quantify the height of the horse, okay? If any of you are horse lovers, you will measure horses in hands, and that's actually where that term came from, okay? Then we have a furlong. A furlong was represented the distance a team of oxen could plow without needing rest. Okay, so these are all the measurements in ancient civilization. And by the way, before I've stressed you all out, I'm not asking you to know any of these. I want you to have a frame of reference for where we're talking about. Hey, what's the problem with all these measurements? The problem is consistency, okay? If this little fella was gonna build a chair for the big fella and he was measuring his hand or his cubit, it's going to be different than that big fella's cubit or the big fella's hand span, okay? So because people are different shapes and sizes, we can't use something that would change with the person, okay? So we realized that some sort of a standardized system needed to happen. So one of the first widespread systems of consistent measurement was called the imperial system. Now, the imperial system was way better than what they were using, obviously. But it's not the greatest system because it's very cumbersome. It uses a lot of fractions, and you'll see that as we go through, okay? But it was a good standardized system, okay? So units in the imperial system, you will hear words like inches and feet and yards and miles, okay? Most of the world, in fact, all of the world but 3 countries have adopted a better system known as the metric system. And we'll talk about the metric system in a minute. Our American friends, though, never adopted the metric system for their life stuff, okay? And why I say life stuff is because in the scientific world, if you are a scientist doing research and you want to publish your research, you must publish in the metric system. You can't publish in the imperial system. So if you're a scientist in the States, you're still using the metric system because that's the only one accepted around the world. But for like if you go buy milk or you are looking at your speed in a car, the Americans still use the imperial system for all of that. Now, we as Canadians have a very close working relationship with the States. And so we get to know both really, really well because we use the metric system in our country, but then a lot of our stuff coming from the States, our trade with the States and our conversations with the States, we need to have a very good understanding of the imperial system as well. Okay, so here is an imperial ruler. Now, an imperial ruler is measured in inches, okay? And I just want to take a second to make sure we unpack this for a second. If I was to count all the tick marks, 1, 2, 3, like that, all the way up to 1 inch, there are 16 tick marks there. That means every tick mark is 1/16 of an inch, okay? Now, to help you read that a little clearer, what I want you to notice is there's different levels of tick marks, okay? So I'm just gonna turn on a highlighter here and I'm gonna color code this for a sec. So the longest one we see here, that guy is the halfway mark. So that's a 1/2 inch. So this here would be 1.5 inches, this would be 2.5 inches, and so on, okay? The next level that you see would be this guy here, and that divides it into quarters, okay? So this would be 1/4, and this would be 3/4. Sorry, I shouldn't have done that with a highlighter, I was just kind of lazy. Now, why did I skip 2/4? Because 2/4, remember, think about fractions, that reduces to a half, and I already did it, that's the pink guy, okay? Then we'll go to the next level, which is these guys. And these guys are eighths. So that would be, sorry, there. So 1/8, 3/8, 5/8, and 7/8. Okay. And then the last guys, the little tiny guys, those would be 16ths. So that would be 1/16, 3/16, 5/16, 7/16, 9/16, 11/16, 13/16, and 15/16. Okay. So to help you with that, because it is important that you can actually read a ruler in inches, there's this website at the bottom here. If you were to click or go to that website, it's www.rulergame.net. It's an interactive ruler where they'll ask you to make a mark on 2 and 3/16. And then you can try and find it. So that would be really good practice so that you are comfortable reading, reading the inches on a ruler and all the segments of that inch. Okay, awesome. Okay, now a referent is another thing we need to talk about here. A referent is used to make measurement tasks easier by establishing benchmarks for certain measures. So it's used when you don't have a precise measuring device available. So maybe you want to figure out the distance of your desk at school, but you don't have any measuring device. So maybe you know roughly how long a graphing calculator is. Receipt attached to it. A graphing calculator is. And so you take your graphing calculator and you say, okay, my graphing calculator, I'm going to measure my screen here. So my graphing calculator, oh, now you see how horrible depth perception I have. Okay, is 1, 2, 3, 4 graphing calculators wide is my screen. Okay, something like that is what we call using a referent. Okay, so how could we measure the length of the room or the length of the desk? The desk I just talked about, maybe graphing calculators. The length of the room, maybe we could do it in people, maybe we could do it in paces. You know, a small pace is roughly a foot, or 3 paces is kind of a meter. Those would be references to give us an idea of the space if we don't have an actual proper measuring device. Okay. Okay, so we're going to fill in this table together. These are all imperial units, okay? I want to make sure you understand that because on tests, I love to say, give me an imperial unit for the length of a football field or something like that, okay? If you answer meters, meters is not an imperial unit, it's a metric unit. So you won't get anything for that. Part of my testing with a question like that is, do you understand the difference between who is imperial units and who is metric units? Okay, so Inch, foot, yard, mile, those are imperial units. The abbreviations for an inch would be IN, for a foot is FT, for a yard is YD, and for a mile is MI. And the one I want to just mention to you right now is mile. Just be super careful with mile. Lots of kids want to put an M there, and you can't, because an M actually stands for meters, okay? So if you have a mile, if you're talking about a mile, make sure it's MI. Okay, so a decent reference for each of these. The inch is the distance from your thumb tip to the first joint, okay? So from there to there. What was that little thing where you could pretend your thumb was off? A little magic. Okay. Your foot. A big foot or a small pace is roughly a foot. A yard is the distance from the floor to the door handle, or your arm span, okay? One arm span, sorry, I shouldn't have done that. I don't have room to do that, but one arm span, remember that's what King Henry did, right? With his thumb, from his nose to his thumb, that's roughly an arm span, so that's about a yard. A mile would be about the distance you would walk in 20 minutes, okay? Now, conversions. I will give you some conversions if you're unsure of them, and we're gonna walk ourselves through conversions in a few minutes here. You never have to know conversion factors, okay? You will always be given conversion factors on your formula sheet or directly embedded into the question, okay? But 1 foot is the same as 12 inches. 1 yard is the same as 3 feet, which also means 1 yard is the same as 36 inches. I just put those two kind of conversions together. 1 mile is the same as 1,760 yards, and 1 mile is also 5,280 feet. So now what we want to talk about is imperial conversion. So that means we're going to move from one type of unit to another type of unit, okay? But right now we're just going to go from imperial to imperial. So there are 2 options for how to show me your work, okay? I really want to stress, I need to see your work. It's really important that you show me something. Some of these things you're going to be like, oh, but I can do this in my head. Great that you can do it in your head, but you need to be able to communicate what's happening in your head, okay? And showing your work is that communication. So pick one of these, and I don't care which one you pick. Some of them will be easier than others depending on the question that you have, but I will show you both for the next little while just to help you get into the groove. So first option would be write the conversion rate and the given value as a proportion and then cross multiply. The second would be to multiply the given measurement by the conversion rate so that the unwanted units divide to equal 1. So let's try a few of these together and see how you're feeling. Okay, so 3 yards to feet. Now again, most of you can do that in your head. That's not the purpose right now. It's to walk through both types, okay? So for the first one, I find my conversion factor. My conversion factor, which I've written right here, is 1 yard is 3 feet. So I wrote that as a fraction, 1 yard over 3 feet. And I set it equal to another fraction. This is called a proportion. Okay, and in the other fraction, I know my yards, but I don't know my feet. So what's important when you set these guys up is if yards was on the top here, yards has to be on the top here. Okay, if I had switched this so that it was feet over yards, then this guy also would have to be feet over yards. Okay, when I go to cross multiply, I go 3 times 3 and 1 times x. So that's going to get me x equals 9. Okay. Then don't forget, you have to give me the unit that you're talking about as well. So x is 9 feet, okay? Now, over on the other side of the blue line there, I'm gonna do it the other way. So I start with 3 yards and I multiply by my conversion factor. The difference here is I multiply by such a way so that my unit that I want to divide out is on the bottom. So yards and yards will divide each other out, and I'd be left with 3 times 3, 9 feet. Okay, so I still get the same answer. It's just 2 different ways of looking at it. All right, let's try another one. Let's go to 3 yards to inches. So again, I need some sort of a conversion factor. I know that there's 36 inches in a yard. okay? If you weren't absolutely sure of that and you couldn't find it anywhere, you could convert to feet and then go from feet to inches. That would be fine, okay? So 1 yard over 36 inches equals 3 yards over x. Again, I'm going to cross multiply. I end up with 3 times 36, which is 108. Don't forget your units in your answer. So important, okay? 108 units. If I was going to do this by multiplying by the conversion factor, again, I just set myself up so that the yards will divide each other out. I started with yards, which means yards has to be on the bottom in my conversion factor, okay? And then I still get 3 times 36, which is still 108. Okay, now this is a very common question, and it really confuses students, so I want you to pay really close attention to this. Convert the following 50 inches to feet, yards. Wow, I'm doing a bad job of this. 50 inches to yards, feet, and inches. Now, the reason this is weird to us is because we don't tend to say this, okay? If I was to travel 2.5 kilometers, okay, we would say, hey, I need to walk 2.5 kilometers to school, okay? But we could say 2 kilometers and 500 meters, because that's what 2.5 kilometers means, okay? We could break it down into 2 different units of measurement, okay? I could say 2 kilometers and 500 meters, or I could say 2.5 kilometers. So what's happening here is the 50 inches is like saying this guy. So 50 inches, okay? And we want to break that down into a statement that looks more like this, where I say 50 inches is this many yards plus this many feet plus this many inches, okay? Now, this is really easy to do if you have your calculator handy. So I want you to have your calculator out, and I'm going to go through this step by step with you. Don't go ahead of me, or else you're going to run into a rounding error, okay? You're going to want to use your answer button on your graphing calculator as much as possible when you're dealing with measurement stuff so that you don't run into any rounding errors. So just a reminder, your answer button is your second function of your negative button for both Casio and TI, okay? So the first thing I want to do is take my 50 inches and figure out how many yards I have. So to do that, I essentially have to divide by 36. I set this up as a conversion factor that I multiply. So 50 inches times 1 yard over 36 inches, that gets me 1.388888888 repeat, okay? Now, what that tells me so far is I have 1 yard. Then I have this piece of a yard left over, which is 0.388888 of a yard left over. Remember, I'm in yards right now. So now I want to take that leftover piece and figure out how many feet are in the leftover piece. So far, my statement says 50 inches is the same as 1 yard and 0.388888889 of a yard. Now, the only reason the 9 is there is because I had to stop the number, but I'm going to take this guy now and convert him into feet, okay? Now, when I go to convert into feet, use your answer button or use however you've set this up in your calculator. Actually, sorry, I just thought about how you set it up in your calculator. So now, if you just want to use that, subtract 1, right? Because we've already dealt with the 1. The 1 is now going to be 1 yard. So subtract 1 in your calculator and then hit enter so that you're just looking at that 0.3888888. Now, to convert that to feet, I would have to multiply it essentially by 3. So now I can just go times 3 in my calculator, and that should give you the 1.166666666. Okay, so now my statement reads 50 inches is the same as 1 yard, 1 foot, and 0.1666666 feet. Okay, so now I want to take this 0.1666666 feet and put that back into inches. So again, you got to get rid of the whole number that's in your calculator, so you can just go subtract 1 so that you're looking at the 0.1666666. And then to get that into inches, you're going to need to multiply by 12, and that should give you exactly 2. Okay, if you follow these directions, it should give you back a whole number. If you type something in, it's not going to give you a whole number anymore because there's a rounding error there now. But if you've done it the way I've kind of encouraged you to do it here, you should get exactly 2. And that should make sense, right? Because we started with a whole number of inches. So there's no reason in this process of converting how we say it, we're not going to lose a piece of an inch or gain a piece of an inch, right? We should still have a whole number of inches. So my final answer is 50 inches is the same as saying 1 yard, 1 foot, and 2 inches. Okay? Now, I know that's a little bit of a different way to think, so let's go through it one more time. Let's do 70 inches this time, and we want to go to yards, feet, and inches. Okay, so kind of a similar question. You should pause me and try it yourself. So what we're going to end up with, we're going to take that inches and go right to yards first. So there are 36 inches in a yard, so I end up dividing by 36 when I set this up. That gives me 1.944444. So that tells me right now I'm at 1 yard and 0.944444 of a yard. I'm going to subtract 1 in my calculator, so I just am looking at that 0.944444, and I want to put that into feet. So I end up multiplying by 3. That gets me 2.83333333. Okay, so now my answer is saying 70 inches is 1 yard, 2 feet, and then this piece of a foot left over, this 0.8333 of a foot, sorry. I want to put that leftover bit into inches. So in my calculator, I'll subtract 2, so I get down to the 0.83333333. And then to convert that to inches, I'll multiply by 12, and that should give me 10. Okay, so your final answer there ends up being 70 inches is the same as 1 yard, 2 feet, and 10 inches. Okay, awesome. Okay, Beth has 12 yards of fabric that will be cut into strips 6 inches wide to make decorative banners for the school dance. How many banners can Beth make? Well, I've got 12 yards of fabric. The first thing I need to do is figure out how many inches that is. Okay, so I use my conversion factor. I know there's 36 inches in a yard. I end up with 12 times 36, which is 432 inches. So altogether, Beth has 432 inches. Okay, now I need to realize that the strips that I make have to be 6 inches wide. So essentially, I need to figure out how many sets of 6-inch wide can I fit in 432 inches. So I'm going to go 432 divide by 6, and that gives me 72. So now I conclude Beth can make 72 banners. Okay, Jace wants to frame a picture. The perimeter of the framed picture will be 142 inches. The framing material is sold by the foot. It costs $1.98 per foot. What is the cost of material before taxes? Well, the first thing we have to figure out is how many feet I need, okay? So I know I have 142 inches. I want to convert that into feet. So I know that there are 12 inches in a foot, so I've set my conversion factor up in such a way that my inches will be on the bottom so that my inches, the inch unit divides each other out. I end up with 142 divided by 12. And that gives me 11.83 feet, and it gives me a super, super important conversation to have. I can't just take 11.83 and multiply it by 1.98. If I do that, I will have the wrong answer. And the reason I'll have the wrong answer is because you can't go to a store and say, hey, I want 11.83 feet. Okay? You have to buy 12 feet if you need 11.83 feet. Okay, this is a super important point because it's what I would call contextual rounding. Even if this answer was 11.2, okay, 11.2, don't you dare round that down to 11, because if you only buy 11 feet, you don't have enough. You're missing 0.2 of a foot, right? So when you're buying material and stuff, you always have to round up to whatever that next number would be. So 11.83, I need 12 feet. And then I know that every foot is $1.98, so I multiply that together, and that gives me $23.76. So it will cost $23.76 to frame that picture. Okay? All right, a map has a scale of 1 to 4,750,000. Now, what that means is, I know this is kind of a weird concept to most of you because, you know, you don't know that there's these paper things called maps before your phones. Before you could just say, hey, Google, how far is it to Edmonton? Oh, sorry, my Google just wanted to ask the question or answer the question. Before you could say that, you would actually have to look at a map, and at the bottom right-hand corner or somewhere around the edge of your map, there would be a scale like this. And what this says is pick whatever unit you want, whether it's centimeters, inches, or whatever, 1 unit on the map equals 4,750,000 units in real life. So we're talking about inches here. So that scale would say 1 inch on the map is 4,750,000 inches in real life. So the distance on the map between town A and town B is 2 3/4 of an inch. What's the actual distance between the two towns? Okay, and then we have to go to the nearest mile as well. So 2 3/4 of an inch, I'm just gonna write that as a decimal, 2.75, okay? Just because 3/4 is a nice decimal, so it's okay to do that in my math. And I have to figure out how many real inches I have first. So that's why I multiply by 4,750,000. Now, just this right here puts me into how many inches it is between town A and town B, okay? And you can see that that's a massive number, right? But then it asks me for miles. So what I'm now doing is I'm taking my inches and converting it to miles. And I did that in 2 steps. First, I took my inches and converted it to yards. I knew there was 36 inches in a yard. So now I'm into yards, right? My inches is gone, so I'm into yards. Then I took my yards and put it into miles. I knew there was 1760 yards in a mile, so now my yards are gone and I'm left with miles. Anything on the top would get multiplied together, and then anything on the bottom would get divided. So how you would actually put this in your calculator is 2.75 times 4,750,000, divide by 36, divide by 1780, and that should give you this 206.163. And then the question says round to the nearest mile, so your conclusion would be the distance between the two towns is 206 miles, okay? All right, so now we want to quickly deal with some measuring devices. Is a ruler always the best way to measure the dimensions of an object or a distance? Well, you know, if you were trying to measure the distance from your house to school, for instance, unless you live in the school's backyard, you probably don't want to get out a meter stick and start counting, right? That would take a long time. So there's other types of measuring devices and measuring tools that you've seen, okay? Determine the most appropriate imperial measurement for the following. So your choices include a tape measure, a measuring tape, a ruler, a meter stick, a trundle wheel, a caliper. Calipers and micrometers are used to measure small things, and often like calipers are used to measure depth. So it's like almost like a vice, but you can put it on the insides instead of the outsides. Micrometer, and then an odometer is what measures your kilometers traveled in a car. Okay. All right. Oops, sorry, I don't have my mouse on here. So let's take a look at each of these and see what we can come up with. Okay, your friend's height, if I'm looking at an imperial measure unit, probably want to do that in feet and inches. You could use a yardstick or a tape measure. The length of a hallway, probably in feet. Probably good to use a trundle wheel. A trundle wheel is it's a wheel with kind of a stick on it, and you hold the stick and kind of walk. And what happens is you hear a click as you walk. And every time that click sounds, it's a particular unit of measure. So it might click for every foot, or it might click for every yard, just depending on how your trundle wheel is set. Okay. The width of your desk, probably you want to do that in inches, and a ruler for that would be fine. the thickness of 10 sheets of paper. Now that's a very small thing, so you would measure that in a fraction of an inch, and you would want either a micrometer or a caliper for that. Distance from school to home, probably you're going to measure that in miles, and remember we're only talking about imperial right now. So probably you want to measure that in miles, and you want to use an odometer. And then the length of a paper clip, again, you're looking at an inch or maybe even a fraction of an inch if it's a smaller paper clip. And a tape measure or a ruler would be okay for those. Okay. All right, so now let's talk about the metric system. The metric system is often called the SI system, and the reason it's called SI is because another word for the metric system is the Système International de Units, which it was signed in France, so that's why it has a French name. So in 1799, France adopted a system of measurement that avoided many of the problems of the other system. The metric system is so much nicer, it's so much easier to use. This system is called the metric system. So this system has been adopted and adapted by different countries since this time. The system became popular because it was easy to convert between different units, okay? And that's what we want to talk about now. Today, all countries in the world use the metric system with the exception of 3 countries, USA, Liberia, and Myanmar. In the scientific community, however, all research must be done in the metric system, okay, even if that research is coming out of the US. Okay, so one little sentence helps you through the metric system pretty easy. King Henry died unexpectedly drinking chocolate milk. Now, from some of your junior high days, you may know a similar sentence. I think it was King Henry died, mother didn't care much. I use the word unexpectedly here, and I use that for a purpose. That is my unit, okay? Now, my unit could be meters if I'm talking length. It could be liters if I'm talking volume, or it could be grams if I'm talking mass. But then these prefixes work for every one of those units, okay? And the prefixes are kilo, hecto, deca, the base, which is meters, liters, or grams, deci, centi, and milli, okay? So literally, if I want to move from centimeters to kilometers, for instance, okay? I look at this and I say, okay, from centimeters to kilometers, I would have to go 1, 2, 3, 4, 5 places to the left. And so I take wherever my decimal place is and I move it 5 to the left, okay? It's so much nicer than dealing with 3/16 of an inch or whatever, okay? So you're gonna like this, I promise. All right. So convert the following. 1,200 centimeters to meters. So if I want to go from centimeters to meters, that's going from my C to my unit. So 1, 2 to the left. Here's my decimal place. I move 1, 2 to the left. So I can say right away, 1,200 centimeters is the same as 12 meters. Okay. So you have to just communicate something to me. So I said C to U is 2 to the left. 1,200 centimeters would be 12 meters. Okay, let's try, sorry, I'm just going to take my ink off there. Convert 0.3 kiloliters to milliliters. Okay, so for kiloliters to milliliters, I got to go 1, 2, 3, 4, 5, 6. So 1, 2, now 3, 4, 5, 6. Anytime I create a little hole there, those are going to be filled in with zeros, okay? So I end up with 6 units to the right, and that's going to give me 350,000 milliliters. So 0.35 kiloliters is the same as 350,000 milliliters, okay? All right, 1.45 grams to centigrams. So grams is my unit. I'm moving 1, 2 to the right. And so that would end up being 145 centigrams. Okay. All right. So there are some conversions here. Again, I already talked about conversions from imperial to imperial. We're going to do it the exact same way when we go from imperial to metric. Either you set up a proportion and you cross multiply, or you set up a conversion factor that you multiply by where your units will divide each other out, okay? These are common conversions that we have to use. And again, you don't have to memorize any of these. They would always be given to you, okay? So you have those same options on how to do that. So let's take a look. We're gonna go, a bowling lane is approximately 19 meters long. How long is the lane to the nearest foot? Okay, so I need to go from meters to feet. So I look at my formula sheet and I find a conversion factor that goes from meters to feet. I am told that 1 foot is 0.3048 meters, so that's what I'm going to use as my conversion. So I set up a fraction, 1 foot over 0.3048 meters equals x, because I don't know the foot, but I need to keep feet on top, over 19 meters. Now I cross multiply, so 19 times 1 divided by 0.3048 is going to get me 62.33596. Then it says round to the nearest foot, so my answer will be 62 feet long. Okay, don't forget to round properly, and don't forget about your units. Okay, Alex is 6 feet 2 inches tall. Now this is a conversation we haven't had yet. Just watch those tick marks. 1 tick mark is foot, okay, and 2 tick marks is inches. So we say that that's 6 feet 2 inches tall. To list his height on his driver's license application, Alex needs to convert this measurement to centimeters. What is Alex's height to the nearest tenth of a centimeter? Well, the easiest thing to do here, you have 2 imperial units going on. Let's make that 1 imperial unit first. Let's figure out how many inches we have altogether, okay? So I know that I have 12 inches in a foot. So I'm going to take my 6, multiply by 12. And that will get me how many inches are in 6 feet, and then add the other 2. Altogether, I have 74 inches. So now what I want to do is I want to look at 74 inches, and I want to convert that to centimeters. Okay, so I need a conversion factor that will take me from inches to centimeters, and I know that 1 inch is 2.54 centimeters. So I set up my proportion. 1 inch is 2.54 centimeters. So I equal that to 74 inches over x centimeters. Cross multiply 74 times 2.54 divided by 1, and I get 187.96. Now it said to the nearest tenth of a centimeter. Now here's another good conversation to have. If I want to round to the nearest tenth, I want to stop there. So I look at the next number. The next number is a 6, which means this 9 has to go up. You need to look at that as 7.9 has to go up to 8.0. Because you were asked to round to the nearest tenth, your answer must have the 10th place represented, okay? So 188.0 centimeters tall. If you had just said 188, that's actually rounding to the nearest whole number. So you got to be super specific in how you answer. Make sure you follow the exact rounding instructions, okay? All right. A truck driver knows that her semi-trailer is 3.8 meters high. The support beams of a bridge are 12 feet 8 inches high. Will the truck driver fit under the bridge? Justify your answer. Okay, so either I have to take my 3.8 and convert it into feet and inches, or take my feet and inches and convert it into meters. Okay, so I'm going to pick on the support beam here, and I'm going to figure out how many meters that is. So why don't we first put it all into inches? So I went 12 times 12. That gives me how many inches are in the 12 feet. And then I added 8. So altogether, I have 152 inches in height for that support beam. So now I need to figure out how many meters that is. Okay, so I need a conversion factor. I can go from inches to centimeters. So that's what I did. I went 1 inch is 2.54 centimeters. So 152 inches is x centimeters. Cross multiply, and I get 386.08 centimeters. Then to convert that to meters, I can go back to King Henry died unexpectedly drinking chocolate milk. I know that there's 100 centimeters in a meter, so that's going to be 3.8608 meters, or 3.86 meters. So the support bridge is, the support beam is 3.86 meters high. Her truck is 3.8 meters high, so she will fit I would not have anybody riding on top of that truck. They might get their head chopped off by the bridge, but she will just fit, okay? All right, so that's it for me on your first lesson. You have some work to do and some practice to do. Please make sure you come and chat with me if you have any questions as you're going through this material. And then next up, we'll start looking at some prisms and some cylinders. Until then, have fun. Take care, guys.